An AI copilot for the mind. Today we are looking at a fascinating study that's completely rethinking brain-computer interfaces. This isn't just some minor upgrade we are talking about. No, this is about giving the human mind a genuine AI copilot, a partner to help it interact with the world. I mean, just think about that for a second. It sounds like something straight out of a sci-fi movie, right? But for people living with paralysis, this isn't science fiction. It's the very real promise of regaining independence, of being able to move and communicate just by thinking. And believe me, we are getting closer than ever to making that a reality. Alright, so let's get into it. The promise of this technology is, well, just incredible, but there has always been this one massive practical problem that's been holding everything back. So, at its heart, a brain-computer interface, or BCI, is basically a bridge. It's a system that listens to the tiny electrical signals in your brain and translates them into commands for something like a computer cursor or even a robotic arm. It's really a direct line from your intention to an action. But here's the thing, the biggest hurdle has always been performance. For decades, using a BCI has often been slow, really imprecise, and honestly super frustrating for the person using it. And that frustration, that difficulty, has been the main roadblock stopping this tech from being used everywhere. And this is exactly where this new research completely changes the game. See, instead of forcing the user's brain to do all of the heavy lifting, these scientists introduced a brand new teammate into the mix, an AI copilot. And this whole idea has a name. It's called shared autonomy. And this really shows you the difference perfectly. Think of the old way as being a lone pilot. You are responsible for every tiny little command, every minor adjustment. But with this new AI BCI model, you're still the pilot. You're still in charge, but now you've got a co-pilot. The user just has to think of the big picture. You know, I want to move the cursor to that icon, and the AI helps with all the fine-tuned movements to get it there smoothly. So, how does this team actually work? Well, first, the user simply thinks about their goal. Then, the BCI decodes that general idea from their brain waves. Now, this is the cool part. The AI copilot looks at the context, you know, the buttons on the screen or objects on a table, to figure out the specific thing the user is aiming for. And finally, they work together, collaborating to make the action happen. It really is a partnership. So the big question is, how did this new team actually do when they put it to the test? Well, the first challenge was a classic BCI task. moving a cursor on a computer screen to hit a bunch of different targets. And the results were, well, they were absolutely staggering. You can see here the performance of one participant with paralysis. On the left, that's the speed without any help. On the right, that's with the AI copilot on their team. The difference isn't just a little bit better, it's a monumental leap forward. We are talking about a 3.9 times increase in performance. Just let that sink in. A task that was slow, methodical, and really difficult suddenly became fluid, fast, and successful. The AI wasn't just a small help, it was a total game changer for the user. This quote from the research paper just says it all. What used to take the user a full 20 seconds to do, they could now get done in just 5 seconds with the AI Copilot. That is a fourfold increase in speed. It's just incredible. So, where did all that extra speed come from? Well, it came from solving what the researchers called the dial-in problem. No, it's that last little bit of the movement, the tiny, difficult, fine-tuned adjustment to actually land on the target. Without the copilot, the path alone took over 4 seconds. With the copilot, a median time of just 0.05 seconds. It basically made the hardest part of the task disappear. And the improvements weren't just about speed. The actual quality of the movement changed completely. With the AI's assistance, the cursor stopped moving in a jerky, erratic path. Instead, it was smoother, it was straighter. It started to look and feel a whole lot more like a natural, effortless movement. Okay, so moving a cursor on a screen is one thing, and it's very impressive. But could this copilot team handle something much harder? Could they control a complex, physical, multi-jointed robotic arm in the real world? And right here, this is probably the single most powerful finding in this entire study. For the participant with paralysis, controlling that robotic arm to pick up and move a block, it wasn't just hard without the AI, it was impossible. He literally could not do it. I mean, just look at these numbers. For participant S2, the success rate without the copilot was zero, a flat zero. But with the AI copilot, it jumped all the way to 93% successful. The system tuned an impossible task into something it could do almost perfectly. And you can see it also gave a huge performance boost to the healthy participants too. It just proves how powerful this partnership is. So, how on earth did it do this? Well, the AI copilot was given another tool, computer vision. It could literally see the table, identify the blocks and the targets, and use that information to help the user perform the really precise actions of grasping and placing the block. The AI basically had its own set of eyes to help the pilot navigate the world. So let's zoom out. What does this all mean for the future of this field? This study isn't just showing us a slightly better BCI, it's pointing towards an entirely new philosophy for how humans and machines can and should work together. The advantages of this copilot approach are just huge. For one, it lowers the intense mental strain on the user, which makes the whole thing less frustrating and way more intuitive. It opens the door to controlling much more complex things in the real world. And as we saw, it can turn tasks that were impossible into goals that are actually achievable. And maybe the most exciting part, as AI gets better and better, these systems are only going to get more capable. Even the authors themselves say it best. They conclude that this idea of shared autonomy is a new way forward, one that can dramatically improve performance now and will only get better as the AI continues to evolve alongside it. And that really leaves us with a pretty incredible thought to end on. We've just seen an AI act as a copilot for physical movement, completely transforming what's possible. It just makes you wonder, what else could we do? What other complex challenges could we solve if we could partner our minds with intelligent copilots? The possibilities really are just beginning to unfold.